All right, let's go ahead and talk now about 7.2 radian measured. So far, we've talked about angles and we've really measured them in terms of degrees, particularly because degrees are what we're really used to. We know that if I go around in a full rotation or a full circle, that's 360 degrees. I can think of a corner being 90 degrees. But in this section, we're going to talk about an alternative way that we can look at the measure of an angle, which we call radian measure. So, what is a radian measure, or what is a radian? So, a radian is an alternative measure for angles, like I mentioned earlier. And if I want to compare it to degrees, there's actually a little bit of an equality that we have. So, in radians, we say that pi is equal to 180 degrees. So we're going to be using this idea pretty much through the entire term. So whenever I introduce this alternative method for measuring angles, one thing that we might be interested in is how do I go back and forth between measuring my angles in terms of degrees versus measuring them in terms of radians. Well, we're just going to use this equality that I have here. So before we go ahead and talk about that, one little just background about this radian measure. So whenever we think about a circle being split into 360 degrees, it is a little bit arbitrary. There are some reasons behind it. There are some origins in multiple parts of the world. Probably the most popular origin is from the Babylonians. But since the idea of degrees is a little bit arbitrary, radians were introduced because, well, a radian is actually the angle that's created by taking a circle and its radius and taking that radius and bending it along the edge of my circle. So by doing this, the radians are give us a little bit more of a universal way to measure our angles. In particular, as you'll soon find out, radians are actually more often used in higher level math after we start leaving from trig. So if you're a student that happens to be taking some future math classes like let's say calculus, for the most part we start using radians from then on. Alright, so that was just a little bit of a background. Moving on to conversions. If I have some angle theta and I want to change it from degrees to radians. So in other words, I have some angle in degrees, but I want it to be given in radians. Then what I have to do is take that angle and I'm going to multiply by pi over 180 degrees. On the other hand, if I have some measure in radians and I want to change it to degrees, then I'm going to multiply by 180 degrees over pi. So this is how we do our conversions from degrees to radians and then radians to degrees. So typically in the beginning for a lot of students in trig, whenever I give an angle in radian measure, most students tend to convert it back to degrees, mainly because degrees is what most people tend to be familiar with. But it may be a good idea to eventually start getting used to the idea of radians because, as I mentioned, starting with this class, we start working more with radians over degrees over time. Alright, so now that we know how to convert back and forth between degrees and radians, let's go ahead and do an example. So example 1, convert the following angles that are given in degrees to radians. So again, if I look at part A, here I have negative 60 degrees. But I don't want this in degrees, I want to measure this in terms of radians. So, oops, actually went back a slide. So if I wanted to convert this from degrees to radians, I had to multiply by pi over 180. Remember, this is how we convert from degrees to radians. Alright, so if I multiply by pi over 180 degrees, one thing that I'm going to emphasize here is that typically whenever we work with radians, then we don't really multiply the pi out. You might be thinking, well, isn't pi 3.14? Yes, but we're going to leave it as some number times pi. In other words, let's go ahead and clean this up. If I multiply this straight across, I'll get negative 60 degrees times pi over 180 degrees. And then I can reduce this. What about 60 divided by 180? Well, 60 goes into itself one time, 60 goes into 180 three times, leaving me with negative 1 pi divided by 3, or just negative pi over 3. Again, notice here that I did not actually say pi over 3. I didn't put in my calculator pi over 3 and got some decimal value. We are just leaving the pi's alone in this case. Mainly because we want to think of this as, well, we know pi is 180, so 180 divided by 3, I go back to 60 degrees. But this is the measure equivalent in radians. Some people like saying instead of radians in terms of pi measures. Alright, let's go ahead and look at part B. Again, I have degrees. I want to convert to radians. I'm going to deal with the same way. I'm going to multiply by pi over 180 degrees. So, if I multiply this out, I get 445 pi over 180. And if I were to reduce this 445 over 180, I can say, well, 5 goes into 445 89 times. 5 goes into 180 36 times, leaving me with 89 pi over 36. If you're not too confident about your reducing fractions, you could always pop this into your calculator and use the nice fraction function to see that it is in fact 89 over 36 times pi. So we just did an example from going from degrees to radians. One little hint that I'm going to note here is, how do you remember that it's going to be pi over 180 versus 180 over pi? Well, there's a reason that we multiplied this as pi over 180 degrees. If you've taken a little bit of chemistry, this might be a little bit familiar. If not, that's fine. Well, right here I have degrees right here. What happens whenever I take degrees, divide it by more degrees? Then they're going to cancel each other out. In other words, my degrees, since they cancel each other out, I'm left with a radian measure. I want to get rid of my degrees, so that's why my degrees is on the bottom. Alright, now let's move into example 2. Similar instructions, but what if I gave you these angle measures, and I tell you these are in radians, but I want to figure out what these are in degrees. And this is going to be a problem that we're going to encounter very often. Starting off with part A, I have pi over 18. So right off the bat, we probably don't know what that angle is in terms of degrees just by looking at it. So let's go ahead and do our conversion. To convert from radians to degrees, I had to multiply by 180 degrees over pi. So what happens here? Well, if I go ahead and try to multiply this out, I get 180 pi over 18 pi. This is me multiplying straight across. So, and now I'm going to try to reduce this. The first thing that I'm going to notice that I can cancel out is that pi divided by pi, I get that they cancel each other out. That is, I get 1. Alright, so I dealt with my pi's. What about my next part, 180 over 18? Well, 180 over 18, that should just leave me with 10 degrees in particular. So this gives me the equivalent measure of this angle, but in degrees. Alright, so now let's go ahead and work on part B. Actually, take a moment here, just like the previous video. Take a moment, pause, see if you can convert this to degrees. Now, if we want to convert this to degrees, I'm going to follow the same method. I'm going to multiply by 180 over pi. If I go ahead and clean this up, I'm actually going to do my reducing from the beginning, because I can see 180 divided by 30, that gives me 6. My pi's can cancel each other out, and then I'm left with 7 times 6, giving me 42 degrees. So I have my example 2, part B, complete. So now we've done examples where we've converted back and forth between our radians and our degrees. I do recommend that you do practice this because this is a skill that we're going to be often using throughout the entire course. Alright, and then that is actually the last example for this section. I'll see you for the next video on 7.3.